Hi everybody, thanks for watching this. Today I'm going to give you an introductory talk about Azure Search, and the title of the talk is Search Like a Pro with Azure Search. I'm going to get into the details why I choose that title, but let's first see the agenda and what we are going to talk about throughout this talk. We are going to see the overview of the Azure Search Service, why we have a new Microsoft Azure service, and what is good for us, what should we do with it, and then we are going to look into the portal experience, how we can manage our search services inside the portal itself. And then we are going to look into the REST API and then what we can do programmatically with Azure Search. Especially, it is the real meat. And then lastly, I'm going to talk about application integration and see what we can do with our existing applications and how we can use Azure Search with our existing applications. So what's the problem actually? Why we need Azure Search in Microsoft Azure ecosystem? When we have our applications, we have data there. And for most of the applications, we want that data to be exposed, want that data to be in an easy reach, so that the user can easily reach out to it, find what he wants to see. But doing this type of development and work is really hard, especially you are working with a traditional database system like SQL Server. SQL Server handles a lot of queries really well, but when it comes to full text search and some complex queries, it struggles a little bit. So, and plus to that, if you want to give a faceted navigation, you are going to struggle a lot more. So it is where Azure Search comes into play actually. It gives us a really rich API to work with it, and then it gives us a really rich search capabilities. So the Azure Search now is a public preview, and we can start using it with the new preview portal. It's not available on the old portal, and it's only available on the new portal. So we mentioned a little bit, but let's dive into the details here. Azure Search is a fully managed software as a service product, and it's hosted by Microsoft, and it offers rich search capabilities. We are going to drill down those capabilities a lot inside this talk. And then the most important part, in my opinion, is it can scale really easily, and you can do even 90 queries per second with it if you scale it rightly. And then it has a rich REST API with you can use with JSON content, and you can do a lot of stuff with it. You can manage it, you can populate your data, and then you can query it especially. So Azure Search application features are full text search, scoring profiles, and faceted navigation, and suggestions, and highlighted hits. These are the bullet points actually, and if we want to drill down those, we are going to see them inside our demos, what we can do with them, how they work inside Azure Search. But if you look at the Azure Search, at its core, it's actually four fundamental parts. One of them is a search service, which is the whole container, actually, if you look at it that way. And the other one is the search unit. The search unit is the scalable part that you are going to use to scale it out in terms of storage size and in terms of QPS, queries per second. And then there is an index part. The index is actually the, if you think Azure Search as a SQL server, it is the table inside the SQL server. And then lastly, there is a document which lives inside the index. So as we mentioned, the search service is the provisioned search, contains provisioned search units, and then it has a few contexts that are targeted to the search service. For example, those are the authentication part and then the scaling part. You can scale your search service, but you cannot scale your index, for example. You need to scale your search service. And then the scaling part is actually done with the search units. You are given a search unit, especially the search unit is you can think of it as actually the virtual machine underneath it, you know. You can scale it out if you want to host high number of documents, or maybe you want only a small number of documents, but you have a lot of QPS. Azure Search gives you a way to do those, and we are going to look into those, how we can do them. Azure Search requires at least 3 replicas in terms of the SLA, and then the total search unit is calculated by multiplying the replica count and the partition count. If you look at the index is actually the collection of documents. It's the holder for the collection of documents. You can think of it as a table inside the SQL server. Index also has the capabilities defined by its schema, and then the search service can contain multiple indexes at the same time. Lastly, it's the document part that we are going to look into. Document part is actually the part that that data will be stored in it. The document has a key which is going to be unique inside the index, and then it has fields, and those fields also has attributes attached to it, such as if the field is searchable or if the field can be retrievable. And then the number of documents an index can contain is limited based on the search units the service has. This means that the index can contain a limited amount of documents, but if you want to go higher with that amount, you need to scale your search service by scaling your search units. Let's look into the search scaling part of the search service and see how it is done actually. Scaling is done by 2 parts. One is the replica part and the other one is the partition part. The partition part is actually the one that you are going to use if you want to scale the number of documents that you are going to host. So you can have 12 partitions, and 12 partitions means actually the 300 million documents. And then you can also have up to 6 replicas. And then if you multiply those, you can have 90 queries per second on top of 300 million documents, which is pretty high if you think that way. If you, for example, if you are on a retail market and you want your catalog to be searchable, and then you want to give facet navigation on top of it, and then you have a lot of products, it's going to be a really easy solution to go with this Azure Search. And if we want to look at the numbers again, we can have up to 36 search units inside Azure Search Service. And then this means that you can have up to 300 million documents inside the search service. And then you can have these documents with 12 partitions. And then you can also have 6 replicas, which is therefore to scale the queries per second. You can have 90 queries per second with 6 replicas. As we mentioned earlier, the Azure Search is also have a portal experience. You can do a lot of things with portal, but it's now limited as it's a preview product right now. So you can create Azure Search services through the portal. You can manage Azure Search Service keys, which are the authentication part of the Azure Search Service. You can also scale your Azure Search Service through the portal. You can scale the replicas and you can scale the partitions as well. Portal also gives us a way to see the usage statistics. By usage statistics, I mean the number of documents inside an index and the storage space that that index has. For example, this statistics don't give us the actually the useful statistics that we need most of the time. For example, like how many times a search I receive a search query which didn't return any results. These are the type of statistics that we need, but Azure Search Service doesn't provide them right now. Let's look at the portal experience by looking at it inside the preview portal. And I'm inside the preview portal right now. And first thing I need to do is to create a search service, Azure Search Service. To create it, I need to hit the new button and then the search section of it. And then it's going to open us the Azure Search Service creation window. And I can type the name of my service. And then I need to choose the pricing tier. This is actually the part that you need to make a decision about how you are going to use Azure Search. There are two options here. One of them is the standard tier, which is going to be the one that you are mostly going to use. And then there is a free tier. Free tier is mostly there as a sandbox experience. You cannot do much with it. You can only have limited amount of documents inside it and limited amount of indexes. You cannot scale the free tier, but the standard tier gives you all the capabilities that we have just talked about. So for your application, you mostly want to go with the standard tier on production. I'm going to choose the standard tier here, and then I'm going to choose a resource group. And then you can also choose the location of the data center. I'm going to choose West US. And I will hit create. And then this is going to be created, but for the preview, it takes a little bit time, approximately 10 minutes, because there is no pooling there for the VMs, so that it's provisioned on the fly. But luckily, I previously created a search service, and then we can look into that. Actually, let me see. I went to browse and the search services, and then you can see my search services here. And let's look at this one, which is a standard search service. And then we can see a few things here. Let's look at them one by one. One of them is the keys. Keys are the parts that we are going to use to authenticate Azure Search. There are two types of keys here. One of them is the primary key, and the other one is the query key. Primary key also has a secondary key to make the transition as smooth as possible. But the tricky part with the query keys are that it cannot be used to create, update, or delete indexes or index documents. It can only be used for queries. This is especially useful if you want to use Azure Search APIs naked inside your client application. For example, you may have a Windows Phone app or Windows Store app that you are going to build, and you can just directly use Windows Azure Search APIs, and then you can work with the query keys there. You can regenerate the primary key and the secondary key here. Let's look into the Manage Query Keys section. You can see that we already have one, but if you want, you can create others here by giving them a name. And then you can start giving them out to your applications. We also have a properties part, which gives us nice information about our Azure Search service. The most useful part here is the scale part, actually. If you look into it, it's actually really easy to scale Azure Search, as we mentioned, but if you look into this, it's extremely easy. You can just scale the replicas if you want, or you can just scale the partition units, or if you want, you can scale them both. And think about this way. Think that you are a retail, you are in a retail business, and the Black Friday is coming up, and you are going to have a lot of customers going into your application. So what you want to have on that day is a really high amount of infrastructure to handle that load. But the second day, you may not need that. So by scaling it in one day and then scaling it down in the other day, gives you a nice way of using your resources flexibly. You can also see that there are usage statistics here. I can see the document count inside my Azure Search service. You can see the storage size as well. This is the portal experience that we get with Azure Search. Let's look into the Azure Search REST APIs. As I mentioned, Azure Search has a pretty nice HTTP API, and it allows us to do a lot of things with it. You can divide them into three categories. One of them is the index management part, and the other one is the index population part, and the last one is the query. You can see the Azure Search APIs in these categories, and it's going to help us understand it better. Index management APIs allows us to create, delete, and update our indexes. By updating, I mean updating the schema, and then also adding scoring profiles is available through the management APIs. And you can also have index statistics through the management APIs. I mentioned that index schema changes are allowed, but there are currently a few restrictions there. For example, you cannot change the schema if that schema is going to result in a re-indexing. So if you try to change your schema in that way, you are going to get a bad request response from the search service. The other one is the index population APIs. Index population APIs allows us to add, remove, or even update index data inside our documents. So you can also do batch operations here to minimize the integration with the server, and then you can also merge them together. You can do upload, or you can do merge, and then you can do delete at one. The last one is the query APIs. The query APIs actually the real meat of the Azure Search REST APIs. Query API supports OData expression syntax, and then they also have a simple query syntax for the search text. And then you can use query APIs with either admin key or the query key. Azure Search is a preview product, but luckily there is this nice community. And then Sandrino Di Mattia released a .NET client for Azure Search, and you can just get it from NuGet or just clone it from GitHub to get started with it. It makes it really easy to get started with Azure Search in your applications. And you are going to see that we are going to use it in one of our examples. Let's drill down to the demos now, and then we are going to have two parts of demos here. One of them is just going to be Fiddler and the HTTP request and responses to see what is actually going on behind the scenes. And the other one is a small application that I have built. It is actually going to work with nearly 350,000 documents inside Azure Search to make it easy to find movies for us. In order to get started with the REST API, we should first create our index schema. Without the index schema, we cannot do any operation on top of our indexes, because it needs us to tell what it is going to be stored inside that index. So here you can see a small snippet that I have for the HTTP request. And you can see that I define my URI here with this search service name. And I am hitting the indexes endpoint. And I also have the API key here. The interesting part is the actual payload. I have the index name here as employees, and I also have the fields here. And a few important things I would like to highlight with the fields. For example, if you look at the first field, which is the employee ID, you are going to see that I have the key as true here, because I need one of my fields to be the key for Azure Search to identify that document. And I also have the other fields, and I have given them the types. And I also have a few interesting attributes here. For example, I have the about field here, and I don't want it to be filterable, because it doesn't make sense for the about field to be filterable. And I don't want to be using this inside my faced navigation tree. So I just mark both of them false. This is nice to have. Every attribute has its own defaults, but you can tweak them if you need them. So if I just run this one, it's going to create our index as you can see, and it gives us the created schema back. Now we have our schema, we can start populating our index. So here I have another request snippet. I am now hitting the employees index, as you can see here, and I am putting this document inside it. But notice that I have the search action as upload. It's because this employee doesn't exist there and I want to insert it there. If I run this one, it's going to give me the results. You can see that it has the status as true. I mentioned that we can do batch operations. Let's do one and see what we are going to get back this time. And this time we got back a similar response, but we have now two results and both have the same status code, which is true. Now let's do some queries and to get back some results. What I want to do is to find any document which has Douglas in it. When we use the search parameter as we do here, we are telling this Azure search to search this keyword that we are giving inside the whole index. By whole index, I mean the searchable fields only. Let's run this one, and we are going to find one document here, which has a first name as Douglas. But notice that we got back a different field here, which we didn't specify. It is the search score field. The score field is given by the search engine to us, and it's calculated by the search engine as well. So it actually gives us how accurate our search with this document is. So if you have multiple results, it gives you a nice way of sorting the results by relevance. Let's run a query which is going to match multiple documents. I am going to now look for rock albums, and now I got back two results, but notice that one has a higher search score than the other. It's because this one has rock albums as a full phase match, but the other one only has rock match. So this is where you are starting to get an idea of how Azure Search works underneath. When you search for a keyword or actual phase, the Azure Search got your input and then separated by space, and then looks for each word separately. And then if you have higher match, and the score will be higher than the other one. However, maybe this is not what I want. I want to match rock albums as a phase, not one word. So I can do that as well with the Azure Search query APIs. I am looking for the same input, but I am looking at it with quotes here now. By putting it inside the quotes, I tell the Azure Search that I want to do a phase query. Let me run this one again. I got back the result, and you can see that I only have one match here, which has the rock albums as the face. Let's see how we can update the document. It's the same as the upload action. One different thing here is I have the action as merge. And the other different thing is I don't need to specify every field here. I only specified what I want to update. So it is the about field here. When I run this one, I will get back the result. And you can see the status is true here. Now let me run the same query again, and this time we are going to match two of them because I have the rock albums inside the third document and the first document as well. We have been doing full text search with the query APIs, but you can also do filters. Filters are a little bit different than the search because filters don't affect the score of the result. They just refine your search. Let me paste this one and then we will look into that. Here you can see that I have the OData expression here, and then I have interests field, and I also have the any operator, and I am telling that I want music. So I want to match any document which has music inside the interest array. When I run this one, I should get two of them. As you can see, both of them has the music as interests. But look at the search score. It's 1 for both of them because filters don't affect the score. You can also mix both of them and then have filters and the full text search run in one query. Here we have rock climbing search here, and then we also have the same filter query that we have just ran. When we run this one, now we can see that the score changed a little bit. As we have the whole match here, it has a higher score. The other one has a lower score than the other. There are more you can do with the indexes, but if you want, anytime you can delete your index. Deleting is really easy. We can just run the delete request on top of the index that we want to delete, which is employees. When I run this one, I'm going to get back 204 no content, which is a success status response. And the other demo that I would like to show you is a little application that I have here. Let me just run it and see what it actually does. As you can see, it's an application for us to search for movies. I have previously downloaded IMDb payloads. They are pretty big, but I extracted them a little bit, and then I do an ETL on it, extract, transform, and load, to put it inside Azure Search. And its code is actually really simple if you look into it. I have two parts here. One of them is the index creation part, index schema creation part, and the other one is the populating the index. What I'm doing with populating the index is getting the data from a file inside my file system and then putting it inside the Azure Search in 500 batches, not one by one. So if you look at it here, you can see that I have nearly 350,000 movies inside my index here. And the tool that I'm showing you is another tool developed by a community member. It's the Red Dog Search, which gives you a really nice way of managing your search indexes and data. With this nice GUI tool, we can look into our indexes and see the schema, and then we can even change it on the fly here. Let's do a search on Star Trek, which is one of my favorite movies, and I'm going to do a search between 2000 and 2010 to see the Star Trek movies. As you can see on at the top, I have a Star Trek movie, and the other ones are the actual TV series episodes. And you can see that they have ratings, and they have the year attached to it. But also notice that at the top I have a navigational properties as well. For example, what I'm telling here is that I have the results that you want, and I also give you the nice navigational properties, which tells you how many movies a year has based on your search query. This is called facet search, and it's very common in these type of applications. I'm running this query on top of 350,000 documents, which is not that high, but if you look at it in a perspective of queries, it's a really high amount of number, and I didn't struggle putting them inside Azure Search. It took me nearly 5 or 10 minutes to put all of them into there. Let's look at the code and how we did that search. Here is the actual controller that I have. This is the get action, and this one is the actual method that handles the query. So I am here creating an API connection. I'm using the Red Dog client here, and I created a query client, and then I built my query using the nice syntax that I have. After I got back the results, I am transforming it into a CLR object. Finally, I also have facet navigational properties here, and then I extracted them as well to see to put it as a navigational property on my page. This was how easy to get it done with a query like that. I can also have pagination if I want here. I can also limit the number of results that I have. I got 100 of them in a page, but if you want, you can just get how many you want. The last thing that I would like to talk about is then existing applications and their integrations with Azure Search. It's pretty common that we have existing applications right now, and we want to maybe take advantage of Azure Search. But how we can do that? How we can integrate our applications into Azure Search? Typical scenario here is that you have an existing data, high amount of data inside, for example, SQL server, and then it's hard to search, and even if you handle that search, it's inefficient most of the time. It's also updated frequently. So with that scenario, what you can do, what are the options for you to integrate Azure Search into your application? The typical solution for that problem is to first of all separate your reads and writes by reading from SQL Azure or SQL Server. You are limiting the amount of queries that you are going to do inside SQL Server. But by doing them inside Azure Search, you are going to be performing those queries really efficiently. However, you want to, you can still store your data inside SQL Server. It's a pretty common approach actually. Then what you can do is updating them as you receive the updates. You can update them inside Azure Search as well. And then you can have a worker process which can run daily or even weekly, depends on your eventually consistency level, to tidy things up. Maybe you can miss things in between because you have 2 transactions there. You can have a worker process that sync the Azure Search with your SQL Server so that you can have consistent data there. And but first of all, what you need to do is to ETL process, which is the extract, transform, and load. You need to get your data from a place and then put it inside the Azure Search, and then you can do incremental changes and updates and then removals if you need. That's what I have today for you, and you can have the resources here. Azure Search has a pretty good documentation, even if it is a preview product. You can go check it out. And there are 2 open source projects, even if it is just released. You can check them out as well. You can see the .NET client and the typical CMS application that it has. Thanks for listening, and hope you are going to enjoy the rest of the conference.